Section 1. Pushing versus pulling. A tale of two processes. Alright, let's get our hands dirty with some serious making. Today we're diving into the world of manufacturing, specifically how we create long, continuous shapes. You see these things everywhere. Window frames, pipes, fishing rods, structural beams. They look simple, but the way they're made is pure engineering genius. The two big players in this game are Extrusion and Pultrusion. They might sound similar, but they are fundamentally opposite in their approach. One is all about pushing, and the other is all about pulling. Understanding the difference isn't just for factory owners, it's for anyone who wants to know how the world around them is built. Think of it like this. Extrusion is like squeezing a tube of toothpaste. You apply pressure at one end, and a perfectly shaped stream comes out the other. It's a push process. On the other hand, Pultrusion is like making your own licorice stick from scratch. You take strands of flavor, pull them through a sticky syrup, and then guide them through a heated tube to form the final solid piece. That's a pull process. Section 2. The push method. Getting into extrusion. Let's start with extrusion, the powerhouse of high-volume production. This is the process for making millions of feet of PVC pipe. This is the process for making millions of feet of aluminum window frames. This is the process for making millions of feet of pasta in your pantry. The principle is beautifully simple. Push soft stuff through a hole. The main machine here is an extruder. For plastics, it's typically a giant screw inside a heated barrel. Raw plastic pellets are fed into a hopper. The rotating screw pushes them forward. As the pellets travel down the barrel, heat and pressure melt them into a consistent, gooey mass, kind of like a river of molten plastic lava. Once the material is properly melted and pressurized, it reaches the end of the line, the die. This is the hero of the extrusion process. The die is a hardened steel plate with a precisely machined hole in the shape of the final part's cross-section. Imagine a cookie press, but for industrial materials. The immense pressure from the screw forces the molten material through this opening. As it emerges on the other side, it holds the exact shape of the die. It could be a circle, a hollow square, or an incredibly intricate profile. It's cooled in water or air and guided on rollers in a non-stop line, then cut into identical parts. Section 3. The pull method. Unraveling Pultrusion. Now, let's flip the script and talk about Pultrusion. If extrusion is about pushing a single material, Pultrusion is about pulling multiple materials together to make a super strong composite. Go-to for parts that must be strong, stiff, lightweight. Think of things like rails on a fiberglass ladder, structural beams for corrosive environments, the shaft of a high-performance arrow. Combining strong fibers with a tough resin. The process is a continuous ballet, pulling, soaking, curing. The journey begins at the creels, large racks holding spools, glass fibers, carbon fibers, aramid fibers. Hundreds or thousands of strands are guided together, sometimes with mats or fabrics for multi-directional strength. The more fibers you use, and the straighter you keep them, the stronger your part will be along its length. Next, the bundle is pulled through a liquid thermoset resin bath. Polyester, vinyl ester, or epoxy. Complete wet-out is critical to ensure a solid, void-free part. Preformers shape the bundle, then pullers draw it through a long heated steel die. Heat triggers curing, locking fibers in a rigid matrix. The exiting profile is fully solid. Section 4. The final verdict. When to push and when to pull. So, you've got a project. You need a long, constant profile part. Do you push or do you pull? It all boils down to two key questions. What do you need it to do? What shape does it need to be? Extrusion is your champion for shape complexity and material variety. Pultrusion is your hero for strength and lightness. Let's lay out the final choice. If your design has intricate details, internal hollows, standard plastic or metal, then extrusion is almost always the answer. It's the master of creating complex shapes efficiently. Think about an aluminum heatsink with delicate fins. That's a classic extrusion job. Or vinyl siding with interlocking features. Again, extrusion fits. The process is fast, repeatable, and works with many non-reinforced materials. But strength is limited to the base material. You can't ask a plastic extrusion to do the job of a steel beam. If strength to weight is your priority, you need to pull. Pultrusion delivers lightweight strength and corrosion resistance, perfect for harsh environments.